Introduction to earthquakes. Earthquakes are sudden, violent shaking of the Earth's surface caused by the release of energy from the Earth's crust. This release of energy generates seismic waves that travel through the Earth, resulting in the shaking and potential damage we experience during an earthquake. Understanding how earthquakes occur and their causes is essential for predicting and mitigating their impacts. Tectonic plates and faults. The Earth's crust is divided into several large and small sections known as tectonic plates. These plates are constantly moving, albeit very slowly. Earthquakes often occur along the boundaries where these plates interact. The boundaries can be convergent, plates moving towards each other, divergent, plates moving apart, or transform, plates sliding past each other. The interactions between these plates, particularly along faults, fractures in the Earth's crust, are the primary causes of earthquakes. Stress and strain in the Earth's crust. As tectonic plates move, they cause stress and strain to build up along faults. Stress is the force applied to a rock, while strain is the deformation or change in shape resulting from that stress. When the stress exceeds the strength of the rocks, it causes the rocks to break or slip along the fault line, releasing energy in the form of seismic waves. This release of energy is what we experience as an earthquake. The earthquake cycle. Earthquakes are part of a continuous cycle involving the buildup and release of stress along faults. Over time, tectonic forces accumulate stress along a fault line, causing the rocks to deform. When the stress surpasses the fault's frictional resistance, it results in a sudden slip or rupture, releasing the stored energy and causing an earthquake. After the earthquake, the fault may settle into a new equilibrium and the cycle begins again. Seismic waves and earthquake measurement. When an earthquake occurs, it generates seismic waves that travel through the Earth. There are two main types of seismic waves: primary P waves and secondary S waves. P waves are faster and move through both solids and liquids, while S waves are slower and only travel through solids. The point on the Earth's surface directly above the earthquake's origin is known as the epicenter, while the origin point within the Earth is called the focus or hypocenter. Seismographs are used to measure and record these seismic waves, helping scientists determine the earthquake's magnitude and location. Earthquake magnitude and intensity. The magnitude of an earthquake is a measure of the energy released at the earthquake's source, typically reported on the Richter scale or the moment magnitude scale. The intensity of an earthquake, on the other hand, describes the effects of the earthquake at different locations, including the damage caused and the level of shaking experienced. The modified Mercalli intensity, MMI, scale is often used to assess intensity based on observed effects. Causes of earthquakes beyond tectonic activity. While tectonic activity is the primary cause of most earthquakes, other factors can also trigger seismic events. Volcanic eruptions can cause earthquakes due to the movement of magma beneath the Earth's surface. Human activities, such as mining, reservoir-induced seismicity, due to the filling of large reservoirs, and hydraulic fracturing, fracking, can also induce earthquakes. These human-induced earthquakes are typically smaller but can still cause significant localized impacts. Earthquake preparedness and mitigation. Understanding the causes of earthquakes is crucial for developing effective preparedness and mitigation strategies. Building codes and engineering practices designed to make structures more resistant to seismic activity can reduce earthquake damage. Public education on earthquake preparedness, including evacuation plans and emergency kits, is also essential for minimizing the impact of earthquakes on communities. Conclusion. Earthquakes are complex natural phenomena caused primarily by the movement and interaction of tectonic plates. The buildup and release of stress along faults generate seismic waves that cause the ground to shake. By studying earthquakes, scientists can improve our understanding of these events and develop strategies to mitigate their effects. Preparedness and building resilience are key to minimizing the impact of earthquakes and protecting communities from their potentially devastating consequences.